PB the science blob. PB, 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 PB the science blob. Science rules. PB the science blob. Whoa, that's so pretty. Where did you get it? I don't remember that decoration from last year.
I grew them myself in chemistry class. Isn't it cool?
Yeah, can I make one?
Well, it's kind of complicated.
That's okay. Please explain it to me. I want to know how they grow like that.
Alright then. It's called a redox reaction.
So, what's a redox reaction?
Well, a redox reaction is when two half reactions are happening at the same time. The red, or the read, stands for a reduction reaction, and the ox represents an oxidation reaction.
But then, what's the difference between the two?
Well, the reducing agent gives the oxidizing agent electrons. Therefore, electrons are gained during a reduction reaction and lost during an oxidation reaction. This is what happened when I made the crystals.
That's so hard to remember.
Well, just remember that the friendly lion named Leo goes grr, and Leo stands for losing electrons, oxidation, and grr means gaining electrons, reduction.
Okay, I think I can remember that. So, what are the half reactions for the crystals?
So, the reduction reaction is a Pb2 plus ion and 2 electrons, which leads to solid lead, and this is the half reaction for it. And the oxidation reaction is a solid zinc breaking into zinc 2 plus ions and 2 electrons, and this is the half reaction for that. And so together, this is their overall reaction. So, the zinc ions fall into the water as they form, and the lead will slowly turn to crystals. In this case, the acetate from the creation of this solution is simply a spectator ion, meaning it does not take part in the reaction.
Wow, PB and zinc sound like pretty cool elements.
They are. In fact, they have special jobs and names in the redox reaction. One of them is the reducing agent, and the other is the oxidizing agent.
Really? But how do you know which one's which?
It's actually kind of complicated. In our equations, Pb is being reduced, making it the oxidizing agent, because it gains electrons. And zinc is being oxidized, and therefore it's a reducing agent, because it loses electrons.
What? So, why is it called a reduction if we're gaining electrons?
Well, as confusing as it is, back in the day it made sense, because protochemists, or early chemists, would smelt their ores to make pure metals, and they would become lighter because some of the metal would be turned to gas, and therefore they thought it was being reduced in terms of mass.
Oh, that's pretty cool. So, is this reaction only found in your crystal experiment?
Not at all. It's found everywhere in life. For example, when plants photosynthesize sunlight into food. That's a redox reaction. Or in the battery powering this very projector, or her cell phone, or his laptop. That's also a redox reaction. Or even fires. They're all redox reactions. It surrounds us everywhere.
Whoa, redox reactions are pretty neat, huh?
You betcha.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty